Hey, all you cool cat mathematicians. Today we're looking at 1-5 mini lesson. We will review decimal place value concepts and how to compare numbers. So last week we looked at first understanding and reading decimals to the thousands place. Today we're going to start comparing decimals, but I do want to review with you those decimal place value concepts and also how to compare numbers. These are the prerequisite skills or skills that you need to be successful with today's lesson. So the last thing, that our big thing is understanding conceptually the math that you are doing. So I put a little quick little comic in there for you. When you confidently answer an equation, a teacher says, I want an explanation, and you're like, I just know, or the math is the math, you know that I want us to dig deeper this year because you were so successful in fourth grade with me. Now it's time to move to the next level of understanding. So one thing I suggest for you to do today is to write or draw a place value chart for decimal place value in your notebook or on your whiteboard to help you compare these numbers and to read these numbers. Some of us are still using that 0.2, 0.123, 0.01 when we read our numbers. And in fifth grade, we really want to move into reading those decimals the right and correct way. That'll help you convert them from decimals to fractions, fractions to decimals. So last week, to conceptually understand decimals, I shared with you that decimals and fractions are both a language that tells you whole number pieces. So if you know 0 and 1, here's my number line. If we were going to say a number smaller or broken up into smaller pieces, equal pieces is a big thing. Equal pieces is a big thing with both decimals and fractions because they have to have equal pieces. If we would break that number 1 up into 10 equal pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that would be our tenths. So we represented with base 10 blocks the number 1 with 1,000 cube. And you know that if you broke that into 10 equal slices, you would have these tenths. So if you imagine those slices going across like pieces of cake, that would be our tenths. If you broke those slices into each into 10 more pieces, you would have these hundreds. These hundreds would make up 100. 100s make up one whole. So if you had 100 of these in this cube, you would have that number one whole. If we decided to split it into tiny little pieces into 1,000 equal pieces, we would have 1,000 of these little cubes. And 1,000 out of 1,000 cubes as a fraction, 1,000 out of 1,000, numerator 1,000, denominator 1,000, would equal one whole. Then we would know that 10 of these thousands would be just one of these hundreds, and 10 of these hundreds would be one of these tenths, and that 10 of these tenths would be 1,000. And that's why we did what we did last week. So let's look at first reading decimals correctly, and then let's look at when you move from left to right on that decimal place value chart, what you're multiplying by. Because remember in the book it said multiplying by tens, multiplying by 1/10, which is really telling you divide by 10. I know a lot of you looked at that and you're like, whoa. So I don't like to write in red. Let me go back into blue. Let's look at reading decimals. So here's my ones place. Remember I had a number line, that would be our ones. And now we're breaking it in. The thing you need to remember is as you go this way on that place value chart, your pieces are getting smaller. Remember, my tenths, now look at my smaller, my hundreds pieces and my thousands. Kind of opposite of when you go this way with whole numbers. So let's look at reading a number. So if I had 0.1, you would just read this number and then say the period that it's in. So this is in the tenths period. So it'd be 1/10. What if I had a number like 0.05? We would say that that is 5 hundredths. What if I had a number that was 0.09? Read that number as 9 thousandths. So what if we start adding a couple digits to these decimals, like 0.12? It's the same concept when you're reading it. That looks like a Z. That's a better 2. I like my whiteboard and my dot camera, but I think you need to see the visuals, so that's why we're doing it this way again. You would read that number, whole number here, or actually not a whole number, but you know what I mean. That's that number, how you would read it normally as a whole number would be 12, and then the place value is hundredths. So why don't I just write a 12 here? Well, remember, we have a base 10 system. You can't have anything greater than 9 in each place value, in any place value from negative infinity to positive infinity, and beyond. Get that? So why? Well, if you think about 12 hundredths, that would be 12 of these blocks. If you had 12 of these blocks, and I made 12 of them, I'm just going to do it real quick for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you regrouped them by tens because remember we have a base 10 system. So when we have groups of 10, we bundle them up. That's going all the way back to kindergarten. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 right there. I'm going to clear those 10 out. You would have one of these 10s. Let me get rid of those 10. Goodbye, friend. Oh gosh, that's not good. Let's undo that. And that is why you would say in that number, in that place value chart, that you would have 1/10 and 200ths, but we would read that as a total of 12 hundredths. Because the largest, really I shouldn't say the largest, the smallest place value, but the one you move to the farthest to the right is hundredths. And you know that you have really 12 hundredths in both of those. So that's why that is written as 12 hundredths. So let's go into this whole idea of times 10 times 1/10. So looking at the number 2 hundredths. If I had 2 hundredths, and I'm asking which number is 10 times greater than 200. So that would be 0.02 or 2 hundredths times 10. Think about if you multiplied these two by 10. You would have 20 of them, correct? 2 times 10 is 20. Each of these are 20. If you had 20 of these blocks, really you have 2 of these ones because there are 20 there and we bundled them up by 10. And if you remember that these are tenths, 2 hundredths, and excuse my sloppiness there, times 10 is really 2 tenths. And that is why. It's that idea of when you are expanding that by 10, you're moving this way in the place value chart. So any time you are multiplying a decimal by 10, you're moving this way. The key concept here is just like in our whole numbers, the digits need to be the same. So you're not going to be changing those digits. So if it's 3 thousandths, and you're multiplying it by 10, if you had 3 of these times 10, you would have 3 of these regrouped. It would be another 3 here. Oh, that's no bueno. And it would be 0.03. The same goes with 1/10 when you are going the other direction. We're really dividing by 10. So if you had 5 tenths, and you're asking for a number of 0.5 or 5/10 times 1/10, you're really saying 0.5 divided by 10. And what they are telling you to do is to take these 5 bad boys here. Is there 5 bad boys? 1, 2, 3, 4, 5, and then splitting them up into groups of 10. Well, if you did that, you would have, what, 50 of these hundreds, correct? So when you multiply that by times 10, you're really saying that you have 0.05 or 5 of those hundreds. One strategy for you to remember that I did not teach you last week is that you can just simply move the decimal point. So if you look at 0.2 and you're saying, I want to multiply this number by times 10, you can move that decimal point over. So if you had 2/10 and you are multiplying it by 10, so that means you have 20/10. Really, you have 20/10 is saying that you would move this over 1, and you have 2 as your number now, 2.0. I cannot draw today, guys. 2.0. And then the opposite could be said if you're multiplying by 1/10. So if you had a number like 0 and 5/10 and you're multiplying it by 1/10, you would just move that decimal point over 1 more to the left this time. So it's the opposite of direction of which I was showing you with the place value chart, because it's doing the math for you that way. So that would be 5/10 times 1/10, or 5/10 really divided by 10 would be 5/100. And it's all about that base 10 system there. I'm almost running out of time here. I want this video to be less than 10 minutes and we're already at 12. So let's look at how we compare whole numbers next. So whole number comparisons use greater than and less than numbers. I'm sorry, greater than and less than symbols. And that's what you're going to have to do today with decimals. But if you had a number like 44,362 and you're comparing it with the number 44,315. And they like to put these right next door to each other and then say, give me the alligator symbol, the greater than or less than symbol. Some of you mentally can look at that and know right away which one to pick. Others are going to need a little bit of a tend to precision strategy. And what I would recommend is you rewrite these and stack them. And that's what you should do with your decimals. And then you can compare going down each place value. So you have your 4s and your 10,000s places are the same, your 4s and your thousands places are the same, your 3s and your hundreds. Now let's look at our 10s. Oh, we know that this one's the greater number. So I would write that as 44,362 is getting eaten or greater than 44,315. And you can apply that same concept with decimals. The last thing I have for you in this mini lesson is this. Let's take a look at which math practice you used. So if I open up our anchor chart, which I'll add that decimal place value chart at the end of that, and we'll talk about that. You today will be using a lot of math practice 7, looking and using structure. You're going to be looking at those patterns. And that comes out in your visual learning when they talk about comparing those numbers. So you cool mathematicians, I wish you luck, and I can't wait to see how you do on your solve and share, and then we can continue with our independent practice. Thank you.